Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so in this video, we are going to continue our discussion on chapter 1, with lecture 4 or 5, the topic of integration, the subtopic of definite integrals. Okay, so let's continue. Okay, so at the end of this topic, students should be able to use the properties of definite integrals, evaluate the definite integral, and determine the area of a region. Okay, let's take a look at the definitions here, where fx is continuous at every point in the interval of a and b, and fx, a big capital letter of f, capital letter of f is an antiderivative of fx. So then, okay, last time we only look at the we call integral of function of fx dx. Okay, without any values is given here. Okay, and now it's for definite integral, they given to you the value of x from a until b, and then once we substitute the value of x into the function that we integrate, then we substitute with fb minus fa. In this case, might be that b is greater than a. Okay. Okay, if fx and gx are continuous on a and b, if the value of x a until a, then it's a 0 here. So then integral of fx dx from a to b, we change the position, means that we substitute a to b. Once we integrate the function, and then we get a capital letter of x of f, and we substitute a to b, then we come up with negative. Okay, as you can see here. And then for question for materials or number 3, we have a c, it's a constant, so we take the c outside, and then we integrate the function of fx. So the rest of it is just a common materials. Okay, now okay, so given integral of fx dx from 2 to 0 equal to 3 and 2 to 5 equal to fx equal to 6, and then the integral of gx dx from 2 to 0, 0 to 2 equal to negative 1. Okay, now for this one here, it's just like integral of 2 fx dx minus 5 integral of gx dx from 0 up to 2 and also 0 up to 2 here. Then 2, what about this one here now? It is equal to 3, right? Equal to 3, so then it is 2 times 3 minus 5. Sorry. And then this one here, it is negative 1. Equal to 2 times 3 equal to 6, negative and negative positive 5, which is equal to 11. And what about this one here now? Integral from 0 to 5. Okay, since we have, for the function of fx, is separate into 2, is for fx from 0 up to 2 and then 2 to 5. So then it is an integral of fx dx from 0 up to 2 plus fx dx from 2 until 5. and this one here 0 to 2 to equal to 3 plus this one here equal to 6, then it equal to 9. Okay. Okay, evaluate this one here now. Okay, so integral of 3x cubed minus 1 divided by x cubed dx. Okay, let's separate this into two parts here. It's just like a minus b divided by c. We can separate into two. Here we get a divided by, no, sorry. A divided by c minus b divided by c. Okay, so then here now, integral of 3x cubed divided by x cubed minus 1 over x cubed dx. So then here x cubed divided by x cubed, integral of 3 minus x power of negative 3 dx. And then integral of, okay, we already simplify between these two, and then 3 minus x power of negative 3. So integrate this one here, integrate, okay, if I separate this into two parts still, okay, 3 dx minus integral of x negative 3 dx. We may integral the function starting from here, but it's okay if I separate it into two, might be very clearer than this one here. So integral of this 3x minus, and this one here x power of, for integration, integral, the index will be plus 1 here, right? You come out with negative 2 divided by negative 2. Okay, so now it's from 1 until 2, 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 and here also from 1 until 2. Okay, meaning we are going to substitute all the x's with 2 first. Okay, actually that if I simplify this, 3x minus negative with negative come out with positive, 1 over 2, and then this one here 1 over 2x squared from 1 until 2. Okay, so then substitute for the first, 3 times 2 plus 1 over 2 squared minus okay, I'm sorry, okay, 3, just now we substitute with 2 here, 2 and 2, and now it's time for 1, turn for 1 here, 3 times 1 plus 1 over 2 times 1 squared. Okay, there's not much enough space here. Let's say if I continue up here, okay, 3 times 2 equal to 6. 6 plus 2 squared equal to 4. 4 times 2 equal to 1 over 8 minus 3 times 1 equal to 3 plus 1 squared is 1. 1 times 2 equal to 1 over 2. 6 minus 3 equal to 3 plus 1 over 8, then minus 3 and minus half, 1 over 2. Okay, change this into 2 times 4 equal to 8, and then 1 times 4 equal to 4. So 3 1 minus 4 equal to 1 minus 4 equal to negative 3 over 8, and then this come out with let's turn this into 8 times 3 is 24 divided by 8. 24 minus 3, 21 divided by 8. Okay, that is the answer then. Okay, evaluate this one here from 0 until pi over 2 cos x over 5 dx. Integral of cos, differentiate cos, negative sign. Integral cos, they give you sine x over 5. Okay, and then differentiate x over 5, come up with 1 over 5. Okay, 1 over 5 here, bring up here, come up with 5. Okay. First, we integrate cos. Cos, it gives you sine x over 5. And then divide by derivative of x over 5. X over 5, come up with 1 over 5. Okay. 1 over 5. And then bring up here, become 5 over 1. Okay, so this is now 5 sine in bracket of x over 5. This is the angle, and this 1 over 5 can turn into 5 here, 5 over 1. Okay, from 0 until pi over 2. Okay, now we substitute the value of pi over 2. First, we substitute 5 sine, okay, x equal to pi over 2. Pi over 2 divided by 5 minus 5 sine x equal to 0. 0 over 5. And this, of course, turning into 0, right? Okay. So then here now, this come up with 5 sine pi over 10 minus, okay, sine 0. Sine 0. What about sine 0? The graph of sine is begin here, right? So sine 0 means that this is everything equal to 0. 0 times 5, 0. So then equal to, if you take a calculator here, you come up with 1.5451. Okay. Okay, class, I checked with my calculator. So that might be recall. We need to double check because I get it here, which is 0. Sorry, what happened? 0.0274. Okay, because this everything equal to 0 here, and then for this one, which is sine, okay, pi divided by 10 equal to 5.483 power of times 10 power of negative 3, and then multiplied with 5 here. It gave you this one here. Okay, you may test with your calculator which one is, because I just get it from the sources of the notes, but this one will press the calculator. So you need, please double check. Okay. So next, evaluate this one here. Okay, so in this case, before we substitute the value of a, x equal to a until b, 0 up to 3, we need to solve everything this first. Okay, for this case, what if I separate, I ignore the value of x, a until b. Let's solve this first. Okay, so from 3x plus 1 divided by square root of x plus 1 dx. Okay. Okay, so for this one here now, okay, for this question, we are going to use the substitution method. Okay, so since that we have, okay, we got the x plus 1 and we compare with 3x plus 1. Before that, okay, let u equal to x plus 1. Okay, we take this term here as our reference, becoming u here, then du equal to 1 dx. And from here, we can come up with x equal to u minus 1. Okay, so we substitute here where 3 and x, where x equal to u minus 1. So u minus 1 divided by square root of x plus 1, where x plus 1 equal to u, and dx equal to du. Okay, do you find any x left here? Okay, I'm sorry, I think that I left something. Okay, 3x, where x equal to u minus 1, x equal to u minus 1. And don't forget we have x plus 1 here. Okay, sorry, I left it. So that du. Okay. Do you find any x left here? No. Okay, it's all turned into u. So then, in that case, let's take a look at the value of x here when x equal to 0 and when x equal to 3. Because everything will turn into u here now, so the value of variable of x equal to a0 until 3 then turn into the new value of u, where u, we use the, recall the equation of u equal to x plus 1. So that when x equal to 0, 0 plus 1, then u equal to 1. Okay, and then here, when x equal to 3, 3 plus 1 equal to 4. Okay. So integrate this 3 times u, 3u minus 3 times 1 equal to 3 plus 1 divided by square root of u du. Okay, so then 3u, negative 3 plus 1 minus 2 divided by square root of u du. Okay. So actually that in this question we use the substitution method. Then So class, I separate this into two parts here. Integral of 3u divided by square root of u means that we're talking about u to the power of 1 over 2. Okay, du minus integral of 2 divided by u power of 1 over 2 du. So take the 3 and 2 outside because it's just a constant. 3 and 2 here. So you come up with 3 integral of, bring this above, okay, u minus u power of half. So u power of 1, u power of 1 divide by u power of half. So divide means that 1 minus half. It become u power of 1 minus half equal to half. Minus 2. Okay, bring this above here. So u power of half, a denominator, bring up here, become u power of negative 1 over 2 du. Okay, so that now it become if I bring up here equal to, okay, integral of u power of half 3, integral of u power of half, then come up with u power of half plus 1, half plus 1, or half plus 2, 1 over 2 plus 2 over 2, 3 over 2 divided by 3 over 2. Okay, minus 2, and integral of this means that half plus 1, half plus 1 come out with u power of 1 over 2 divided by 1 over 2. Okay, and then bring this, okay, divide by 3 over 2, bring this above here, come out with 3 times, switch the position upside down, so equal to 3 over 2, bring up here, become 2 over 3, then u power of 3 over 2 minus 2, and this one here, bring up here, become 1 over 2, bring above here, become 2 over 1 or 2, and u power of 1 over 2. Okay, now divide, then you have 2 u power of 3 over 2, and minus 2 times 2 equal to 4 power of 1 over 2. Okay, so class, from here, from 0 to 3, and we turn it into the value of u, which is 1 until 4, 1 until 4, 1 until 4. Okay, so 1 until 4 and 1 until 4. So then also here from 1 until 4, 1 until 4, 1 until 4. Okay. So it's time for us now to substitute the value of u and u with 4 here. Okay, the first is we substitute 2u power of 3 over 2 minus 4u power of half, and turn it all the u with 4. So 2 times 4 power of 3 over 2 minus 4 times 4 to the power of half. Okay, and minus, again, this term where substitute the u and this u with the value of u equal to 1. So 2 times 1 power of 3 over 2 minus 4 times 1 to the power of 1 over 2. Okay, so look at this one here now. 4 to the power of 3 over 2. 3 over 2 means that it is square root of 2 and power of 3. So square root of 4 equal to 2. 2 power of 3 equal to 8. Again, this 2 is a square root, right? So square root of 4 equal to 2. And 2 power of 3 equal to 8. 8 times 2 equal to 16. Minus square root of 4 equal to 2. 2 times 4 equal to an A. Minus, okay, 1 power of 3 over 2 is still 1. 1 times 2 equal to 2 minus square of 1 is 1 times 4 equal to 4. So 16 minus 8 equal to 8. 2 minus 4 equal to negative 2. Negative times negative positive. So then 8 plus 2 equal to 10. Okay. Next. So these all the properties of definite integrals. So please try to understood, which I think that is easy. Okay. At the end of the lesson, to determine the area of the region. So class, let's say we integrate the function of y or fx to the x from x equal to an a, where x equal to a, we begin with 1 here, 1, 2, we divide into pieces here. Okay, divide into pieces the area from x equal to a until b, we divide into pieces 1, 2, 3, 4, 5, and 6. Okay, so from x equal to a until x equal to b. Okay, from here, to estimate this area from x equal to a until x equal to b, divide into n strips, and since each of the strips approximate to a rectangle, we can sum the areas of these rectangles. Okay, area of rectangles, this is, okay, one rectangle, okay, this one, one rectangle, rectangle number 2, rectangle number 3, 4, 5, and 6. Area of one small rectangle, width times with the height, equal to width of the rectangle here, delta x. So as n approaching to infinity, delta x approaching to 0. So we come up with an integral of fx dx is equal the value of x from a until b. Okay, try to understand because I'm not going to explain too much here. So area of region bounded by the curve y equal to fx and x equal to fy. It's important to sketch the graph of the curve, given curve, in order to identify whether any part of the required region lies below the x-axis or not. Okay, whether any part of the required region lies below the x-axis or not. Okay, the key point here is important to sketch the graph, okay, of the given curve in order to identify whether any part of the required region lies below the x-axis. To find the area below the x-axis, we always need to consider absolute values of the definite integral. Okay, never mind. So the area of a region bounded by the curve of y equal to fx. This is y equal to fx. The x-axis, here the x-axis, x equal to a and x equal to b. So this is the area. Area or a equal to integral of y dx, y equal to fx from x equal to a until x equal to b. And this one here, class, if we integrate this function, okay, integral of this function of fx dx from x equal to a until x equal to b, you will get the answers of this area with negative value. Okay, because it lies below the x-axis. The point is, is there Okay, can you imagine a negative area? Okay, it's not a negative area, but then negative shows the direction or the location of the area which is below the x-axis, where area must be always positive, right? Okay, so negative, in this case, negative doesn't show you the area. We call the size of the area, but then is a position which is below the x-axis. Okay, that's why we come up with a sign of absolute values. Okay, now first one here. Okay, find the area of region bounded by the curve of y equal to x squared plus 1, x-axis, the line of x equal to 1 and x equal to 2. Okay, now let's sketch the curve of this. Okay, y equal to x squared plus 1 is a curve that cuts at x, y-axis at y equal to 1. Okay, this is a curve of y equal to x squared plus 1. And the lines of x equal to 1 until x equal to 2. So this is coordinate of x equal to 1 and this x equal to 2. Okay, so this is the area. So then find the area integral of x squared plus 1 from x, okay, dx from x equal to 1 until x equal to 2. Okay, so then let's integrate this. Integrate x squared respect to the x, you come out with x cubed divided by 3 plus with 1 in integral of 1 dx, x 1 until 2. Okay, now it's time for us to substitute all the x's with 2 first. So then 2 cubed divided by 3 plus 2 minus 1 power of 3 divided by 3 plus 1. Okay. 2 cubed equal to 8 over 3 plus 2 minus 1 over 3 here and minus 1. 8 over 3 minus 1 over 3, 7 over 3. 2 minus 1 equal to 1. Make this one here as an 1 equal to 3 over 3. So 7 plus 3 equal to 10 over 3 unit square. There you go. Sorry then. Okay. Example 2. Calculate the shaded area bounded by the curve of this one here. Y equal to x squared plus 2x. X-axis line equal to x equal to 1 until x equal to negative 2. X equal to negative 2 stated here. Okay. So now we got two areas of P and Q that we need to consider before we need to find the both of the areas of P plus Q. But this one here, let's find out whether we can get a positive or negative. Okay. Let's say if I integral of this, the area from negative 2 until 0 of the function of x squared plus 2x dx plus as we call area from 0 until 1. 0 until 1, x squared plus 2x dx. So just imagine that this is P plus Q. Okay. So now integral of this, it come out with x cubed divided by 3. Integral of x squared respect to the x cubed divided by 3 plus 2x squared divided by 2. Okay. From -2 until 0 plus with, okay, now it is x cubed divided by 3 plus 2x squared divided by 2 from 0 until 1. So 2 divided by 2. 2 divided by 2. And now the first one here, we substitute this x and this x with 0. So 0 cubed. 0 of 3 equal to 0 divided by 3 is 0, and also 0 squared is 0. Make it 0 here. Okay. Minus, then substitute with -2. -2 cubed equal to -8/3 plus with -2 squared. -2 squared equal to 4. Has with, okay, now 1 cube. 1 here, x 1 cube equal to 1/3. Okay, plus with 1 square equal to 1 minus, okay, 0 cube divided by 3 equal to 0. 0 square is also 0. Okay, look at this one here now. 0 minus, so minus, what about this one here now? Make this, turn this 4 into a fraction with the denominator of 3. 4 times 3 equal to -8/12 plus 12 divided by 3. Oh no, 4 times, okay, I make a mistake here, sorry then. This one. Okay, 8/3, and then 4 times 3 is 12/3 plus with, okay, this one 1/3 plus 1. So 1/3 plus 3/3, 4/3 minus 0 is 4/3. Okay, look at this one here now. -8 plus 12. -8 plus 12 is 4, right? 4/3. (4/3) plus 4/3. Well, look at this one here now. This is negative. This represent the area of P, which is below the x-axis, and the area of P is negative, right? Negative is not the size of the area. It shows the position or location of the area which is below the x-axis, and the area is negative. So that's why we come out with this sign. Absolute values for P. There you go. And now, absolute values of -4/3 can turn into positive. So 4/3 plus 4/3 equal to 8/3 units squared. Because it's an area, so it's a unit squared. Next, the area of region bounded by the curve of x equal to fy and y-axis and the lines of y equal to c until d. So then, the area we start from c until d here. We start integral of x dy from d and c until d. Okay, and just like just now we're talking about the area below the x-axis. Now it's talking about the area on the left side of y-axis. Left side of y-axis, then the area will become negative, and this one is positive. Find the area bounded by the curve of y equal to x cubed, the y-axis and the line of x, y equal to 1 until y equal to 8. So y equal to x cubed. Sorry, what's wrong with it? Okay, y equal to x cubed, and the graph, checking that is something like this, right? So guys, this is a graph of y equal to x cubed. Y equal to x cubed, and then the lines of y equal to 1. Y equal to 1. Sorry, there's something wrong with this one here. Y equal to 1 until y equal to an 8. Okay, you sketch on the paper nicely then for this one here. Okay, now integral of this y equal to x cubed, integral to the y-axis, with respect to the y. So then y equal to x cubed, x dy from 1 until 8. So from this equation of y equal to x cubed, then x equal to y to the power of 1 over 3. Get it? From y equal to x cubed, okay, something like that here. I write it down here, y equal to x cubed. So we want it in the term of x equal to fy. So then, this one, power of 1 over 3, and also here, power of 1 over 3, and x equal to y to the power of 1 over 3. Okay, get it? So now, this is integral of y power of 1 over 3 dy from 1 until 8. Okay, so then, integrate this. Is y power of 1 over 3 plus 1, 1 over 3 plus 3 over 3, 4 over 3 divided by 4 over 3. Okay, from 1 until 8, which is, bring this above here, turn the position upside down, 4 over 3 come out with 3 over 4, y to the power of 4 over 3, from 1 until 8. 3 over 4, okay. So now, equal to, substitute with 8 first. So, 3 over 4, 8 to the power of 4 over 3 minus 3 over 4, 1 to the power of 4 over 3. Okay, look at this one here now. It's a cube root. Cube root of 8 equal to 2. 2 power of 4. Cube root of 8 equal to 2. Okay, so then 2 to the power of 4 equal to 16. minus cube root of 1 equal 1 power 4 is 1, and then minus 3 over 4. 16 divided by 4, 4. 3 times 4 equal to 12 minus 3 over 4 equal to 11, 1 over 4 unit square. Get it? Okay. Next. Okay. Find the solution of, find the area of shaded region measured by the curve of this one here. X equal to 2y minus y square, and the line of y equal to negative 1. This is y equal to negative 1. What about this one here now? What about this? Okay, from here, y and y, 2 minus y. So y equal to 0, and this one, 2 minus y equal to 0. 2 minus y equal to 0, then negative y equal to negative 2, then y equal to 2 here. Okay, so then the area, which is, okay, I name this one as an A1 and this A2. So that A1 plus A2 integral of 2y minus y square dy, first from 0 up to 2 plus with 2y minus y square dy from negative 1 until 0. Okay, so then here now 2y square divided by 2 minus y cube divided by 3. Okay, this one here from 0 until 2 plus with, okay, 2y square divided by 2 minus y cube divided by 3 from negative 1 until 0. 2 divided by 2, 2 divided by 2. Substitute y and y here with 2 first. 2 square equal to 4 minus 2 cube equal to 8 over 3 minus, and substitute with 0 here, 0 and 0, everything is 0 here, plus with, okay, substitute with 0 here and here, everything with 0, minus, and substitute with negative 1. Negative 1 squared is 1 minus negative 1 cube, negative 1 divided by 3. Okay. So 4 minus 8 over 3. 4 times 3 equal to 12. Turn this 4 into a fraction with the denominator of 3. So 4 times 3 equal to 12. 12 over 3. 4, which is 12 over 3 here. So 12 minus 8 equal to 4 over 3 minus 0. This one minus 0 plus with, this is 0, and then negative 1 minus negative 1. Negative times negative, positive. So 1 turn into ratio with a denominator of 3, which is 3 over 3. 3 over 3 plus 1 over 3, positive and negative. 0 minus 4 over 3. Okay, so class, this is 4 over 3 plus with negative 4 over 3. Now, why did we get this is negative 4 over 3? Please remember that the area on the other right side of y-axis is positive, and the area on the left side of y-axis here come out with negative. So that's why we come out with absolute values. Okay, absolute values here and here and also here. So simplify this. 4 over 3 plus 4 over 3 equal to 8 over 3 unit square. Okay, next. So region bounded by the curve of fx and gx. So in this case, class fx minus gx, because if I sketch this, okay, the graph of the red, and then this is the blue one here. Okay, the intersection point between these two, when x equal to a until x equal to b. So once, okay, let's say this is an fx and this is an gx. Okay, so now let's say if we integral the function of fx, integral fx from a to b, it gives us the whole area between the fx and x-axis. Okay, and then minus gx. Integral of gx also gave us the area between the curve and x-axis. So then now, the whole area between the fx and x-axis minus the area between the curve of gx and x-axis, the red line here, then this is the area that we get. So this is the area, the result of the R, as you see here. Okay, so then, and also here the region bounded, because integral of x fy, the red one here, it gives you the whole area between the curve and also y-axis minus the area of gy here between this curve and y-axis. Okay. Okay, find the area of the region enclosed by the curve of y equal to square root of x and y equal to x cubed. Okay, let's sketch again. Sorry. Okay, y equal to x cubed. Y equal to square root of x. Something like this. Okay, and then this is y equal to square root of x and y equal to x cubed. Y equal to x cubed. There you go. Y equal to x cubed. Okay. And now this is an intersection point. Find the area of region enclosed by the curve of y1 here and y2, square root of x and x cubed, which means that it's the area between these two curves. It's got nothing to do with x-axis or y-axis. By the way, we need to find the intersection point of this, because we find the first intersection is here 0. So let y1 equal to y2. Square root of x equal to x cubed. Okay, so we squared both left and right. So in clear between these two, then x equal to x to the power of 6. So then x minus x to the power of 6 equal to 0. Then x minus, no, let's make this one as a bring this x, so then x6 minus x equal to 0, then x equal to x power 5 minus 1 equal to 0. So then x equal to 0, then x equal to 1. So this is x equal to 1. Okay, now we are going to integrate this to the x, meaning the area from the curve to the x-axis. Okay, now to find the area between these two, which means that we need to find that a1 minus a2. a1 integral from 0 until 1. Okay, now we determine the area where the graph of y equal to square root of x, y equal to square root of x is above this graph, right? Okay, so this comes first, square root of x dx minus integral from 0 until 1, and the graph below this one here is y equal to x cubed, y equal to x cubed dx. And for this one here, what if I change it into x to the power of half? Okay, so integral of this x power of half dx, x power of 1 over 2 plus 1, 3 over 2 divided by 3 over 2 minus, this is x to the power of 4 divided by 4. And both of these from 0 until 1. Okay, from 0 until 1. Okay, now bring this above here, turn the position upside down, we come up with 2 over 3 x to the power of 3 over 2 minus x to the power of 4 divided by 4 from 0 until 1. Okay, I clear all this. And mind, this is a video that you can just simply refer to this. I click the button of rewind, forward, pause, and then play, stop. You know all the button then. Okay. So now, equal to, substitute x with 1 first. Okay. If I substitute this here, meaning, look at this one here. First, we integrate from 0 until 1, meaning we getting the area of all this. Okay, so this is the area of x power of half dx, or square root of x dx, the area of all this, minus this one here, meaning the area between the second curve, or y equal to x cubed, okay, the whole area of this minus this area, then you get the area between these two curves. Okay, so substitute with this one here, x equal to 1, so 2 over 3, 1 power of 3 over 2 minus 1 power of 4 divided by 4 minus Okay, and then 0. 0 here and 0 here. 0. Okay, so 2 over 3, 1 power of 2 over 2 is still 1 power of 3 over 2 is still 1. So 2 over 3 minus 1 over 4. 12, 3 times 4, 2 times 4 equal to 8 minus 4 times 3 and 1 times 3 equal to 3. So 8 minus 3, which is 5 over 12 units squared. Okay, so what's next? Okay, the conclusion, which I think that you can refer to these notes. Okay, so 2 exercise for all of you with the final answer provided here. Okay, so please try and test yourself. That's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.